Assalamu alaikum. Bismillahirrahmanirrahim. Thermochemistry in Americas.
Here is the 11th question of the chapter of your 11th chapter of your textbook of 11th class, and this question is about bomb calorimeter. You may read it either from your textbook, this question, or from the screen you are watching now, and you may read this question from the screen as well. Now, write data which is given in the question. That is, a mass of the camphor which is given 0.1204 grams. Heat of combustion that is given 5903.6 kilojoules per mole, and the temperature increase in temperature 2.28 degrees Celsius or 2.28 Kelvin. And next you are to find the heat capacity in this question. We are also required molar mass of camphor. Formula camphor is C10H16O. So its molar mass is 152 grams per mole. So tabulate this data and then you will proceed to solve this question. All these values except molar mass are given in question. Molar mass is to calculate from the formula that is given of the camphor. While solving question, it is mandatory that one can understand with the help of units that which amount has been given and which is required. You know that here enthalpy of combustion or heat of combustion of 1 mole is given, whereas mass is not that of 1 mole. So from the enthalpy combustion per mole, you need to calculate enthalpy of combustion or heat of combustion for the given mass of the camphor. So 1 mole of camphor, which is equivalent to 152 grams of camphor, will produce heat on combustion 5903.6 kilojoules, and 1 gram of camphor will produce 5903.6 divided by 152, and the given mass is 0.1204 grams. So 0.1204 gram of camphor will produce heat, and the result will be 4.676 kilojoules. So this is the amount of heat that is obtained when we burn 0.1204 gram of camphor. Heat obtained is 4.676 kilojoules only, not moles. We are not required here in enthalpy of combustion for 1 mole, but instead we are required for the given mass. We know that formula for the heat evolved in the bomb calorimeter is heat evolved equal to change in temperature or rise in temperature into total heat capacity of the calorimeter. In this particular case, we have been asked to calculate the heat capacity. So first you write that C, that is total heat capacity, is equal to Q divided by delta T, where Q is heat evolved. Now here you are to put that value of heat evolved which is according to the mass that is given in the numerical and which is burned in the bomb calorimeter. So only this something is that needs need attention in this question. Otherwise, it is a simple and straightforward question. Now put the values of Q and delta D in the formula. You solve it and finally you get your answer. We know that C is equal to Q delta T and Q is 4.676, which we have calculated in our previous slide, and it is divided by delta T in or increase in temperature is 2.28, and finally we get our answer, which is equal to 2.051 kilojoules per Kelvin for the given mass of the camphor. Okay, that is simple and straightforward question. I hope that this video will be helpful to you. AR chemistry is always endeavoring to facilitate all those who want to improve themselves.